Assalamualaikum and greetings to Dr. Adi and fellow friends. My name is Ms. Shazwina binti Saharum. My matrix number is 208222 and today I will be presenting about engineering application of matrices in equation with my partner Joanna. So first, what is matrix? Matrix, when some numbers are arranged in rows and columns and they are surrounded by square brackets on both sides, we can call it as matrix. There's few types of matrix that we know of. Some of them are row matrix, square matrix, column matrix, and many more. So now I will pass to my partner Joanna.
All right, thank you, Lisa. Before I begin, I would like to greet our lecturer, Dr. Adi, and introduce myself. My name is Joanna and my matrix number is 207631. And I will be talking about its application of matrices, especially in engineering. Okay. So in computer engineering, there is a term called cryptography, and it is related to computer security. Its function is to secure computer systems, and in this case, we are talking about confidentiality. It means that no one else other than the intended audience can decipher the data transferred on the computer's network. One of the ways to achieve that is by encryption. Encryption is about translating a data into another form or code that can only be accessed by someone who has the secret key to read it, while decryption is the other way around. Decryption is the conversion of the encrypted data into its original form. So to make things clearer, we are going to proceed with some examples of encryption and decryption using matrices. So now I will pass to Miza first to begin with encryption. So back to you, Miza.
So thank you, Joanna. So now we'll be solving the first problem. The first problem is using the matrix B, given here matrix 3 times 3, encode the message attack now. So on the top left, we have here the codes for each letters. So let's go to the calculations. First, we have to divide the letters into groups of 3. So since there's a space between attack and now, the space will be covered with the dash. And since W will be the only letter left, we'll also put dashes to make it into a group of 3. So now, once we have the groups of 3, we can put it into column and we can put each of the codes for each letter. So this is what we get in the step number 2. Next, we can move on to the step number 3. For step number 3, we have here matrix B, and we will multiply it with each of the column that we have already gotten in the step number 2. So for the example here in number 3, I have multiplied the matrix B with the first column for the letters A, T, T, and this is what I get, 12142. So you have to multiply for each of the columns with matrix B, and once you have done that, you will get the codes like we can see here in step number 4. So that is all for me today. Thank you. Now I will pass it back to Joanna.
All right, thank you, Lisa. So for my part, I will talk about decryption as promised. For decryption, once again, I repeat, it is about the conversion of an encrypted data into its original form. So in problem 2 here, it asks to decode this message. It's basically asking us to find the original message based on this encrypted code given. And it's been said that matrix B here was used to encode the message. So to do that, we are going to proceed with some calculation. So first things first, since matrix B was used to encode the message, we need to find the inverse of B. And then the next step is we need to multiply each of the matrix on the left with the inverse of matrix B. Do that, and then finally in step 3, this is the resulting matrix, resulting value after we have applied all the matrices here with the inverse of matrix B, and we get these values. So now what we have to do is just replace all these numbers with its corresponding letters, based on the table here. So the final message that we get here is hold fire. All right, so basically that is all for me, and that is all from us Team 5. We've reached the end of our presentation. Hope y'all learned something from this, and thank you for watching.